awesome things like that. So each team will have 10 minutes to present with a little Q&A after that. It'll be a fairly conversational presentations. And yeah, I think we should just go in order. So team one. Oh, yeah. Sorry, Till. I'll make my assessments about your raise after I've seen your presentation for the engineers. Yeah, so let's start with team one. Let's get it started.
I think Chris is going to share a screen. There it is. All right, I'm just going to kick it off. Say we're Team Arctic. We were tasked with making an application that plays the game Werewolf for our client. If you guys aren't familiar with Werewolf, it's similar to Town of Salem if you ever played that. It's a voting disqualification system. Maybe Among Us familiar with that. Basically, there's 2 werewolves for 7 players or more players. It scales up that can kill villagers. There's villagers who can vote off wolves during a day and night cycle. There's a doctor who can keep somebody from getting killed, and the seer who can see people's rolls. And your job is to be very convincing and win whatever side you're on. So it's interesting constraints because we need to have several different parameters, day and night cycles, timers. We also need to have roles and individual views for any given player at any given time. We need to be able to reference everybody. We need to be able to reference each game state. So we decided to go with object-oriented design principles. Basically, we can instantiate a new game at any given time with given parameters. We can instantiate a new player class as well and populate that game class with the given player class for each person who makes a connection. So I'm going to pass stuff to Chris, then he could talk a little bit about the logic behind that as well.
Yeah, sure. So I am Chris, and I was on the team that handled the some of the game logic and the game loop that makes this function. Just so you know, I'm signed in. This is my computer. I'm signed in as 7 different people, but this is deployed to AWS. You can sign in from anywhere, have whatever name you want. After we're done, we're going to send out the link so everyone can actually jump in and play games if they like later. But essentially, what we ended up doing, like Alex was just saying, we implemented object-oriented programming. And what we decided to do for the game loop is that when a game is created, a game object is made. And we effectively pass that game object around through a loop of functions that keeps looping until the win conditions are met. So here in the lobby, we collect everyone that's there. We press play. We go to the first phase, which is the pre-game, where you learn what role you are. This person's a werewolf. This person's a villager. Werewolf again, seer. All those various roles, right? And once this is done, this would be the phase where everyone talks about who they are, kind of gets to know each other. The game's meant to be played in a Zoom chat room as well. We go to the night phase. So now the object has been passed over to the night phase function. And in this phase, the werewolves can vote, wherever a werewolf is. You can vote on who you want to kill. And at the end of the day, one person is killed who got the most votes. You can see here in the middle. Then it goes back to the day phase. And in the day phase, everyone votes on who they think the werewolf is. And the werewolf, whoever gets the most votes gets killed, as you can see. And the werewolves go back to their thing. Let's see if I can find someone with a different role. That's another werewolf. All the other interesting people are dead. And then once the win conditions are met, right, the object gets sent over to the end game condition. And you can loop back and get sent back to the lobby and play again. And I'm going to hand it over to Danny.
Thanks. So obviously, it was very important to have that constant two-way interactive communication between both the client's browser and the server. And the way we did that was by using WebSockets, specifically Socket.io. And so generally speaking, we basically implemented a bunch of emitters and listeners on both sides. So both the client side and the server side. So for the login, start game, messages, votes, all those are emitted on the client side, received on the server, and then distributed amongst all the clients. And on the server side, we would emit things such as the game phase, the game end conditions, timer, and more. So there's always this two-way communication. And generally speaking, yeah, but Jonathan will go into a bit more detail about that.
Okay, let's take a deeper dive into the wonderful world of what the heck Socket.io is doing. So I worked on login functionality, adjustable game settings, and game in progress logic. So for login functionality, effectively, there's a listening event on the server. It's just sitting there listening for someone to click that login button. And on client side, login click emits from the client to the server, which the server then populates a logged in list. Then that emits to everyone to keep them all up to date on who's actually logged in. And it updates the list of clients on that home screen. The same is effectively happening on any of the change settings. It works in the same way as controlled components, but instead of changing state on change, it's emitting the change to the server. So the server is effectively storing the new change and updating everyone on change. Restart logic is essentially similar. That one's actually about erasing the game object from the server, which then re-renders everyone back to the login screen because the game object is no longer in existence. And it gets ready for a new game. So overall, the main challenges with sockets is just setting up those listeners and triggering the right emits at the right times. Off to Darian.
Yeah, so going off of that, expanding on the power of sockets, we really have this live real-time chats where the werewolves can communicate with each other. As you can see, Chris 5 sent a message, and then the other werewolves can see it as well. What we did was we set up a listener on the back-end server, which is essentially, you think of it maybe like a post route. And then once the client or the werewolf types a message in the chat, it'll emit that message, send it to the server, where the server will emit that message to all the werewolves. And there wasn't really too many challenges with this because we had the game state stored with all the usernames and IDs. So we can simply just loop through the ID, match it with the usernames, and then see who's emitted that message. And with that, I'll pass it on to Robert to talk about some more challenges with our workflow.
Yeah, one of the primary challenges our team faced this project was in regards to agile workflow. Early on, there was considerable overlap in our individual components. In particular, the front had a number of parts that required the game state logic to properly implement and test. As a result, we did a considerable amount of pair and group programming just to keep everybody in the loop. And this may have been slightly inefficient at first, as we had multiple people working on the exact same problem, but it helped considerably in the end, as we had very few merge conflicts. And then post feature freeze, the same problem came up again when we all moved on to styling, but because of the prior experience and planning, we were able to quickly remedy this with some efficacious communication and some solid teamwork. And I'll hand it off to Irene.
Yeah, so as you can see with our CSS, we have basically two screens that you're going to be viewing as a player. You're going to have your login screen and your gameplay view. And so with the CSS, there's a lot of conditional rendering that's happening behind the scenes. So not only are the sockets taking care of that on the server side, but we also have that on the client side. Like the day and night, who's getting killed, who gets to see the werewolf chat, those kind of things. And then some future features that we would like to build out after the program ends are, so multiple games can be played at the same time using Socket.io and namespacing. As well, we'd like to have a leaderboard so that, because we have a database built, so we'd like to get that functioning and working, connected to the front end, so that as people play this over time, we can have who's been the best werewolf and who's survived the most games. And that's it. Thank you guys for listening.
Awesome. That was amazing. Just the amount of stuff you've done in such a short amount of time. I had the pleasure of play testing yesterday, and it was a very, very fun experience. So we have plenty of time for questions. So if you want to put your names in the chat underneath this line, Team 1 can take some questions. And yeah, you can just unmute and go if it's your turn for questions.
Is the game state available in the console if you know, say I was playing and I wanted to cheat and figure out who the werewolves are? Can I check that out in the console?
Of course you'd ask that question. If you want to ruin it for everybody, sure.
You might have to dig a little, but yeah.
Yeah, you could probably find it.
Yeah, I want to point out, we actually evaluated that risk early on. We were thinking about storing some information server side, but just to simplify the thing, get the minimum viable product go, we just decided to send the whole game state out to the clients.
Yeah, I think we could easily take care of that in the future, but yeah, like Alex said, for the time we had, it was the easiest way to get it up and running.
Any more questions?
I just wanted to add that I know a few people were trying to implement the multiplayer features for their projects, and don't be intimidated. It's super easy and convenient once you kind of get a hang of it, and I recommend playing around with Socket.io when you have a chance.
I had a quick question. In terms of your object-oriented stuff and the game state and players and stuff, how many, what classes did you have? Like a game class, player class? Did you have to make separate werewolf subclasses? How did that all kind of look?
It was just one game class and a player class. Each player class had a role and a live status, and then there was a vote count targeted to it as well. So we didn't do any subclassing. It was just one additional parameter.
That makes sense. Sounds like a great way to implement it. Yeah, if there's no other questions, we can move on to object class as a player array. Oh,